So this is an example of how to solve with a radical when we have polynomials involved. So the first thing is, before I can do a whole lot with this equation, I'm going to have to get rid of the radical. The problem being I have this plus 7 here. So I'm going to move the plus 7 to the other side by doing minus 7 so that I can address the radical issue. Once the radical is alone, then I'm able to address it. But until that point, I can't. So I get q minus 7. Now, like I talked about in my week 1 videos, the way to get rid of a radical, because it's a 1/2 exponent, is to raise it to the second power. So if you didn't get to watch that video, you need to go back and watch that video in the lecture videos. When I square it on the left-hand side, I'm going to get q squared minus 19q plus 19. Now, q minus 7 squared is the same thing as q minus 7 times q minus 7. Because I'm going to have to get all of my variables on the left-hand side, I'm going to need to FOIL that. So I'm going to have first, outer, inner, last. And what I'm going to do at this point is move all of my terms over to the left-hand side so that I can solve. And what's going to be nice about this is when I subtract the q squareds, we're going to have a nice simplification. So while what's under the radical is not a perfect trinomial, it doesn't affect my answer. Because when I square this, those squareds, I'm going to minus q squared and minus q squared, and they're going to cancel. So then I'm going to add 14q, and I'm going to add 14q. And that's going to give me negative 5q plus 19 equals 49. I'm going to subtract the 19 from both sides. So I'm going to get negative 5q equals 49 minus 14 would be 30. So q equals 6, negative 6. So what the question becomes is that an actual solution for what's under the radical? So to find that out, I'm going to take that negative 6 and plug it in. So when I do that, I'm going to get 36 plus whatever 19 times 6 is, plus 19. So I know the solution works because I get a positive number under the root. So I don't have an extraneous solution. An extraneous solution would happen if I had a situation where I got a negative number under the square root. So whenever we're dealing with radicals, we always want to go back and check our answers. And so what we do is once we solve it, we're going to plug it back in and make sure we don't get a negative number to have an imaginary number under the radical. So again, even though it's not a perfect trinomial, that's not going to matter here because when I get rid of the radical, the q squareds are going to cancel out.